This is my solution to the cereal problem. So we had 8 stores, only 8 stores, and I stole this from another textbook, to be honest with you. I almost think that this is real data, though. The 8 points are shown in the scatter plot below, and I fitted a linear regression, which is what this other textbook asked us to do. And I asked you, how do you like the model? I really kind of like this problem because it illustrates what Tukey was talking about back here. So what Tukey said is you have to do the best you can with rather weak indications from the data in hand. So with only 8 data points, we don't have a lot of data, and our indications are quite weak. We may have to draw on our experience with other data sets that we've analyzed like this, and draw on our subject matter expertise. And so even if all 3 of these may not suffice and we need rules of thumb, so log, counts, or amounts. So let's go back and look at this problem. When I look at the scatter plot, it doesn't look horrible. You can't say too much with only 8 data points, but it's not I've seen worse fits in my life. Let me put it that way. If you were to go generate a residual plot, which I did in R, you're going to notice a few things. Maybe there's some lack of fit here. Maybe there's a little bit of heteroscedasticity, but don't get too excited about 8 data points because you just have so little data. It's really hard to see the problems. But let's draw on some subject matter knowledge. Do we really think this relationship is linear? So if it's linear, then we could just keep increasing the number of facings to infinity, and our sales would then also go to infinity. And is that reasonable? So if I filled my whole store with shelving for cereals, would I sell that much more? Would it just keep going up linearly? And I think the answer to that question is obviously no. You would expect, just thinking about the problem, some diminishing returns where, if I have if I double my shelf facings from, a half a meter to a meter, maybe my sales go up quite a bit. But if I go from 1 meter to 1,000 meters of shelf spacing for cereal, it's not going to keep going up in a linear way. So therefore, we would expect some decreasing returns on facing. We've got 2 amount variables here. Both sales and facings are counts or amounts. And what Tukey said is you probably want to log it. And, sure enough, we could go log it, and let's just go try that. I actually tried it before I started making this video. And this is the log plot. This is your fitted regression line. And to be honest with you, the scatter plot doesn't look that much different from the original one. But I think there's perhaps, I may prefer the log model to the linear model because of what Tukey said, that we've got 2 counter amount variables, and the fact that log facings is going to, in a sense, take care of some diminishing returns for us. The residual plot doesn't look that much better, to be honest. You still have that nonlinear pattern in there, but again, it's only 8 data points. So I think this illustrates Tukey's points very nicely of having very limited data, but having to make a decision. I'd probably go with the log model on this.